Unit 4, Congruent Triangles. So Unit 4, Day 4, we're going to prove triangles are congruent using 3 additional postulates, and they are angle side angle, and angle angle side, and this one is called HL. Okay, turn to page 10, and that is your notes page. In this unit, we will learn 5 ways to prove triangles are congruent. We've already talked about side, 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 so all we need is 3 pieces of information. 3 sides of one triangle, congruent to 3 sides of another, and hey, the triangles are congruent. We talked about side, angle, side. We need an angle between 2 congruent sides, a congruent angle, and 2 congruent sides, and we can prove triangles are congruent. So now today, we're going to talk about the remaining 3. So we're going to start off talking about angle side angle. With angle side angle, you're going to have a side that's congruent to a side in another triangle, and it's going to be between congruent angles. So here we go. In this unit, it's very important that you mark given information, and we'll keep repeating myself on that. So here, what do we have? We have angle B is congruent to which angle? Angle E. What is the side? We name a side with 2 letters. So side AB is congruent to side DE. We got our angle, we have our side, we need another angle. So which angle is congruent to which angle so that we can have angle side angle and be able to prove the triangles are congruent? You got it. Angle A is congruent to angle D. So now we want to write our congruent statement, and our congruent statement will be triangle ABC is congruent to triangle DEF. That's our congruent statement. So it's very important that we mark given information. So side SQ bisects angle RQT. Well, here is angle RQT. The word bisect we associate with equal. So if that segment is splitting that angle, we have 2 congruent angles. Take a look. Not only does it bisect angle RQT, it bisects angle RST, which is over here. What does that mean? Then these 2 angles are congruent as well. So we have our markings. Now, what do we notice about this picture? Oh, there's a shared side. So when I take a look at this, I can see I have an angle in my top triangle that matches an angle in my bottom triangle. I have an angle up here in my top triangle that matches an angle down here in my bottom triangle. And then I see in the middle that I have a shared side. Mark it with another color. So if you can see this, this is going to be angle, side angle, and over here angle, side angle. So let's get ready to write the proof. The reason for number 1, you got it, it's given. When I look at RQS in my picture and TQS, it was not given, but we can determine that or conclude that by the definition of bisect. Okay, if something bisect, something is congruent, and therefore that's the definition. Same with number 3, those angles are congruent because of the definition of bisect. The segment split it into 2 congruent parts. What happens when we have QS is equal to itself? Remember from the last section, this is the reflexive property. Reflexive. Let's take a look at how we can prove these triangles are congruent. Which postulate is it? Let's see. We know side, side, side is 1. We know side, angle, side is 1. And now we're working on angle, side, angle. What do we have? You got it. They are congruent because of the angle, side, angle postulate. Let's take a look at number 2. Let's figure out what the given information is. I'm given that JK is parallel to LM. So there are my markings. I'm also told JL is parallel to KM. Okay, I have that marked, and I need you to know that anytime you see parallel lines or the markings, it's going to indicate some type of angle relationship. Okay? Okay, so number one, this information exists because it was given. Now let's take a look here. Angle J to K to L. I'm going to go from J to K to L. So that's this angle in here. And then M to L to K. M to L to K. So that's this angle over here. What is that angle pair relationship? Well, it's actually alternate interior. And alternate interior angles are congruent. Alternate interior. Well, let's take a look at J to L to K. Let's go from J to L to K. And that's this marking over here. And then we're going to go from M to K to L. M to K to L. So that's this one here. And why does that exist? You got it, alternate interior. Okay, we have KL is congruent to itself. When you see something is congruent to itself, why is that? Oh, it's a shared side. And the reason for that is the reflexive property. Anytime something is shared, we can say it's congruent to itself. It is the it is the reflexive property. Let's take a look at what you see. This is angle, side angle. This angle, this side, this angle corresponds with this angle, this side, this angle. So that's angle, side, angle, and over here, angle, side, angle. All right, let's take a look at this one. Always read and always mark. When I take a look, it says segment YZ, which is right here, bisects. Anytime you see bisects, that means something is equal. So it is bisecting angle WYZ. Start at W, go to Y, go to WYX. Always concentrate on the letter in the middle. So from W to Y to X, that's actually this angle right here. And so if it is bisected, then this angle is congruent to this angle. There we go. It's also giving us another piece of information. Any other piece of information is that YWZ, let's take a look at that, YWZ, this angle over here in the corner, is congruent to YXZ. Start at Y, go to X, go to Z, so we're concentrating on X. And so those two are congruent. So what do we have so far? I see an angle here, and I see an angle here, which is congruent to an angle over here and an angle over here. But we need one more piece of information to prove these triangles are congruent. Well, we were looking to have a side in between the two angles, but we don't have it. But take a look over here. This one says that we can prove it if we have an angle, and a side. And look at here, we have that. I go from an angle to a side, and over here an angle to a side. So I've pre-planned, and I can see what direction I'm going into. So now I can begin to write in my statements and my reasons. Here goes. So number 1 and number 2, they were given. So let's see what's next. Okay, so angle WYZ is congruent to angle XYZ. Why is that? Because the definition of bisect. And now we have YZ is congruent to YZ. It's a shared side. And what property is that? That is the reflexive property. Now we have the triangles are congruent, which is what we were trying to prove. WYZ is congruent to triangle XYZ. Which postulate / theorem can we use? The AAS, which is the fourth postulate for proving triangles are congruent. Okay, I can't stress enough how we need to mark given information. given information. So this says angle ABC is congruent to angle CED. What we want to make sure we do when we look at this is we always want to concentrate on the letter in the middle. That's the vertex. So if I go from A to B to C, I'm actually concentrating on letter B. If I go from C to E to D, then I'm really concentrating on angle E. Also, I'm given that line AB is parallel to CE. Now, we talked about it last time. When you're given parallel lines, there's going to be an angle relationship. However, keep reading. C is the midpoint of AD. So here is C right here, and it is in the middle of A to D. Anytime you see the word midpoint or bisect, automatically we think equal, two equal parts. So I need you to mark that if C is the midpoint, two things are equal. Well, what's equal? A to C is the same as C to D. Okay. One thing I want you to think about is that we have these parallel lines. We have an angle-pair relationship. I don't see alternate interior, but I do see corresponding. Take a look at this angle that corresponds with this angle. Now we're thinking through before we actually get to this proof. So let's see what we have. We have an angle, we have an angle, we have a side. We have an angle, we have an angle, we have a side. Do not say that this arrow here makes this side congruent to this side. That arrow just means that it's parallel. So now let's write in the given information. All right, let's see what we have. Well, the first three pieces of information are all in our given statement. So we don't have a definition or postulate for it. What do we know? It was given. So let's see where we go from here. Well, we know that AC is congruent to CD. And what was the reason that AC is congruent to CD? Got it. Definition of midpoint. The next thing we need to do is we need to see why angle BAC is congruent to angle ECD. Why? Take a look at it. Angle BAC, which is this angle right here, A, is congruent to ECD, which is this angle here, C. Well, you got it. They correspond. So let's figure out what we have now. Corresponding angles. So when I take a look, I have an angle aside, and an angle aside. And so these triangles are congruent. Triangle ABC is congruent to triangle CED. Why? Because of the angle side postulate. Here we go. I can't stress enough. Read the directions and mark up the information. So PR bisects, we talked about anytime you see bisect or midpoint, something is equal. So PR bisects angle QRS. Angle QRS, so that's concentrating on angle R. So now we know that it's split it into congruent angles. It's also telling us here that angle PSR, which is angle S, is congruent to PQR, which is angle Q. So let's go ahead and mark that. These are congruent. So that's the information that we have. We have angle, and over here we have angle. What else do we need? We need another side. So we've brainstormed, and we can clearly see that we have an angle, and a side, and an angle, and a side in the middle. So let's get this written up. So we start off by writing down our given information, and this is going to help us move towards proving the triangles are congruent. Okay, so we have PRS is congruent to PRQ. Why are those angles congruent? Because of the definition of bisect. That segment split it into two congruent angles. Here, PR is congruent to PR. I just can't reiterate enough. that that's a shared side. And anytime you have triangles connected by a shared side, it's the reflexive property. So last but not least, we tell why these triangles are congruent. And here you have it. They're congruent because of angle side. Well, our last postulate for proving triangles are congruent only has two letters, and the letters are H and L. Well, hypotenuse is only going to be in a right triangle. So what is it that you have to look for in order to prove hypotenuse leg? Well, you have to have a right triangle. Okay, and you have to have one leg, just one, congruent to another leg, and the hypotenuse congruent to the other hypotenuse. So the hypotenuse, if you can remember, is the side that is across from the 90-degree angle. So let's go. The hypotenuse is segment BC. So if we can show that segment BC, which is the hypotenuse in one triangle, is congruent to segment EF, which is the hypotenuse in another triangle, and then all we need is one leg. So if we can say AB is congruent to ED, that's enough information to prove the triangles are congruent. So now we can say the triangle ABC is congruent to triangle DEF. So here's the kicker here. The hypotenuse is across from the right angle. And the leg is a side that's adjacent to the right angle. So here's the right angle. This is what's across. And these are the legs that make up the right angle. So let's practice. So here we go. We want to know, are these triangles congruent? Well, the first thing I see is I see right angles. So maybe they could be congruent by hypotenuse legs. So I do want to check it out. So do I have a leg that's congruent to a leg? And the answer is yes. So I have a leg that's congruent to a leg. But we need more. We need a hypotenuse that's equal to another hypotenuse. Well, take a look. The hypotenuse is across from the 90-degree angle. Do you see any markings? No. Over here, you see any markings? No. Can we say that this side is congruent to that side? No. So are these triangles congruent? And the answer is no. Here's another practice one. I have these two triangles, and what I notice right away is I have a right angle. So if you have one right angle and this is a linear pair, guess what? Then the other side is a right angle too. So I know if I see a right angle, I do want to check hypotenuse leg. So I want to check hypotenuse. Do I see a hypotenuse in one triangle that's congruent to a hypotenuse in the other? Well, where is the hypotenuse? Across from the right angle? Yes. Across from the right angle? Yes. Is it marked? Yes. So the hypotenuse is equal to the hypotenuse. I don't see another leg. Do you see where a leg is congruent to another leg? I don't either. Oh, wait a minute. In the middle, that is a shared side, which is a leg. So do I have one leg that's congruent to another leg? Yes, I do. The question, are these triangles congruent? Yes. Why are they congruent? Because of the HL postulate. And you are now ready to do some practice work.